Welcome everyone to the IMC seminar. It's a very 2020 event. It's the 1st of September. Term is starting up in Aarhus. The university is now formally open for researchers and teachers as well. It used to be only for students. So I guess we are approaching some kind of new normal, and being in that new normal precisely means navigating a mixed reality. So some people are teaming up in the meeting room at IMC, holding a nice distance. Some of us are sitting down along the alley at the IMC, and other people are spread all over the world. And that's probably how IMC seminars will be in the autumn. We plan to keep the meeting room open if possible. You might need to book a space in advance if spaces begin to fill up. And otherwise, you're most welcome to join online for all of these events here. The program is fully booked for the autumn already. We have just acquired some new FNIRS equipment, and a number of the seminars will be introductions to FNIRS, what can you do with FNIRS, etc. There's also going to be a number of talks by people who have received seed funding as a way to feedback on what has happened. And then it's kind of a mixture of local people or people joining in virtually from all over the world during the autumn. But stay tuned at the IMC website to see what happens there. And with that, without further ado, on to Riccardo.
So it's nice to see you all again. It's also nice to see all the students in the audience. It is my pleasure today to introduce Marieke, who's an interdisciplinary scholar who researches the many ways in which we understand each other. And in a perfect interactive minds fashion, she merges in interesting ways internal cognitive perspectives like theory of mind and perspective taking with interactional processes such as communication and repair. Marieke did her bachelor and master studies at the University of Amsterdam, where she combined linguistics, psychobiology, and cognitive science. And then she followed up with a PhD at the University of Edinburgh on coevolution of language and mind reading under the guidance of some friends, Simon Kirby and Kenny Smith. And now she's a postdoctoral fellow with Woensdregt Dingemanse on interactional ways of doing mind reading, for instance, through on these. Yeah. Sorry.
Oh, sorry, I lost connection for a minute. I don't know if it was just me, but...
No, we lost you for about 10 seconds there. Sorry.
Oh, sorry. I was just saying that as we started working together on a Marie Curie project, it became very clear the power of weak ties. So having these friends of friends, colleague of colleagues made it very easy for us to work in a very productive way. And I'm really proud of and impressed by the project that Marieke mainly has developed. And I look forward to hear her talk about this. And I hope that you will give us comments on making this even better and make sure that Marieke comes to ours.
Okay, thank you very much, Riccardo, for the lovely introduction. Yeah, so I'm not sure which camera to use. I really apologize if I'm not looking straight at everyone. Before I start, I just want to mention that the way I'm going to structure this talk is that I'll mostly be presenting this new research proposal that Riccardo and I have developed for this Marie Curie grant application. But in doing so, I will also talk about some of my previous work, computational modeling work, so some work from my PhD and some ongoing work from my current postdoc, which kind of formed the inspiration for asking this research question that this proposal is focused on. But yeah, I'm just saying this to warn you that there will be some finished work, but towards the end, I'll be presenting an experimental design for which there aren't any results yet because that's our research proposal and we haven't run the studies yet. Also, before I start, I just want to say that you should all feel free to interrupt me during my talk. So yeah, if you have any questions, I will probably not see it if you raise your hand or something. So if you have a clarification question, really just start talking and I'll respond. So yeah, without further ado, let's start with the title of the proposal, which is Aligning Minds, Cultural Coevolution of Language, Perspective Taking, and Conversational Repair. Now, the central question of this proposal is, how did humans evolve the ability to communicate successfully? And the particular challenges that we're thinking of when we're asking this question are the fact that natural languages, as we find them in humans, come with a significant amount of ambiguity on different levels. So there's ambiguity on the word or morpheme level in the form of homonymy and polysemy, but there's also structural ambiguity, etc. And to make things worse, natural language also comes with underdeterminacy. So this is the idea that if you hear a given sentence, say, I'm tired, you might know the literal meaning of those words, but depending on the context, the implied meaning or the speaker's communicative intention can be many different things. So for instance, I'm tired in one context might imply, I'm tired, I want to go home from this party or whatever. In another context, it might imply, I'm tired, I'm considering quitting this job that I've been complaining to you about, etc. So what this concept of underdeterminacy tries to capture is the idea that we cannot derive the speaker meaning or the communicative intention of the speaker purely from the literal meaning of the utterance. We need to take into account the context and the speaker's mental states and so on. So more specifically, the question of this proposal is, how do we, despite these challenges, nevertheless manage to reach mutual understanding? Now, we're not the first people to ask this question, luckily. So a number of different, I call them coping strategies here, have been proposed to help us overcome these challenges, to allow us to reach mutual understanding. One of them is perspective taking. So this is the ability to see things from someone else's point of view, and thereby, sorry, I'm just rearranging my setup, thereby allowing, for instance, a speaker or producer of an utterance to reason about what utterance is most likely to reach the desired result in their interlocutor, but also the other way around, it allows the listener or receiver to reason about what the speaker's most likely communicative intention was. So perspective taking is a cognitive mechanism that can be used by an individual by themselves. So it's an internal mechanism. That's in contrast to this other mechanism of conversational repair, which is an interactive mechanism. And repair describes this phenomenon where a listener or receiver of an utterance indicates that they had some trouble understanding the utterance. And through the way in which they indicate that trouble, the speaker or producer can then somehow repair or clarify their original utterance. I'll go into perspective taking and repair in a bit more detail later on. But just to mention that there are also other mechanisms that have been argued to help us build common ground and thereby help us reach mutual understanding, such as interactive alignment and back-channeling. But in this proposal, we chose to focus on perspective taking and repair, partly because the role they play in negotiating meaning and reaching mutual understanding is quite tangible, and partly because they are somewhat straightforward to manipulate in an experimental paradigm for which we have a proposal, which I'll describe later on. Okay, so in a bit more detail, what do I mean by perspective taking? I use perspective taking here in a very broad sense of being the ability to see things from someone else's point of view. So this can be actual visual perspective taking, but it can also be someone's point of view, as in their view on the world or their view on a particular topic. So quite broadly construed. Although in the experimental design that I'll be presenting later on, we will be using visual perspective taking as a way to kind of operationalize this phenomenon of perspective taking. And as I briefly mentioned already, in communication, perspective taking has been argued to be relevant for the producer to be able to choose utterances that are likely, or the utterance that is most likely to make their receiver infer their communicative intention. So this is, so what the producer is doing here is also known as audience design or recipient design. And it has been argued to be used by the receiver to infer the likely communicative intention behind that utterance. So what does the speaker really mean, or what do they want from me with this utterance? And in a bit more detail, what do I mean by other-initiated repair? As I said, this is a mechanism that is interactive. So it happens between multiple individuals, and it allows a receiver to signal trouble in understanding a given utterance. For instance, because there was some environmental noise, or because the utterance was ambiguous, and so on. And the fact that the listener indicates that trouble, as well as the way in which they indicate that trouble, allows the producer to then either repair or clarify their original utterance as needed. There's been a lovely study, oh sorry, I should go back to this reference of Dingemanse and colleagues from 2015 in +1, where they compared 12 different languages from 8 different language families, and they took data, video recordings of very naturalistic conversation, and found that the same system of other-initiated repair is used across these very different languages from very different language families. And what they found in particular was that there are 3 main repair initiator types that are used in different circumstances, and that the principles governing which repair initiator to use are also similar or the same across languages. So those three repair initiator types are the open request, which is, say, if a speaker said this sentence, Sibby's sister had a baby boy, if the listener says, huh, that is an open request by which they indicate that they had trouble with the entire utterance. For instance, because it was obscured by noise, or because they were just not paying attention, or it really came completely out of the blue. And usually an open request, or usually the speaker or producer responds to an open request by simply repeating the entire utterance. The second type of repair initiator is a restricted request, which a listener can use to point to a specific part of the utterance that they had trouble understanding. So in this case, by saying who, they indicate that they only had trouble with the subject of the sentence. And then that allows the speaker, of course, to specifically repair or clarify that part of their utterance. This is another example of a restricted request, she what, by which the listener indicates, I only had trouble with the predicate part of the sentence. And the third type of repair initiator is a restricted offer, which is where the listener or receiver basically gives a candidate understanding for the part of the, or a candidate meaning or understanding for the part of the sentence that they weren't sure about or had trouble with. In this case, Jenny. And that allows the speaker to, if that's correct, simply confirm and they can move on with their conversation. Or if it wasn't Jenny who they meant, then they can specifically clarify or repair that part of their utterance. Another example of a restricted offer is a boy, and they can again confirm or clarify as needed. And what this big cross-linguistic study of Dingemanse and colleagues found is that the way in which these repair initiators are used by listeners across all these different languages ensures that the collaborative effort of speaker and listener is minimized. So the listener or receiver is not simply being lazy or egocentric and just saying, huh, whenever they had trouble understanding the utterance. Instead, what the listener or receiver does is to always use the most specific repair initiator possible. And that allows then the speaker to reply or respond in the most to the point way possible. And together, that allows them to move on with their conversation as quickly as possible. So together, they're minimizing the joint effort or time needed to do this repair procedure, and they can then move on with their conversation. A lot of research has already been done on how or to what extent humans use perspective taking in communicative tasks. A lot of work has also been done on how or to what extent humans use repair, both in naturalistic conversation, but also in more task-oriented contexts of referential communication games and things like that. But the focus of our proposal is on the possible two-way interactions between these two mechanisms and the emerging communication system. So really, our questions are about the cultural evolution of a language. And we have reason to believe that these interactions might not be unidirectional. So it might not just be the case that perspective taking and other initiative repair are mechanisms that support the building and establishing of novel communicative conventions, but there might also be positive feedback the other way around. So the building or establishing of novel communicative conventions might help humans infer each other's perspectives or learn about each other's perspectives. And having novel structure, systematic structure in a communication system emerging might actually make the system of other initiative repair more efficient. And the motivation for these two hypotheses comes from agent-based modeling work that I have done in the past, so in my PhD and during my current postdoc. And I will now first discuss those two projects that have led to those two hypotheses. And then once I've motivated these hypotheses, I will then move to the actual research proposal. So the actual experimental design and so on. But just to give a brief preview of the experimental design, we propose to use the iterated learning paradigm in order to investigate the emergence and cultural evolution of a novel communication system. Now, this is a tried and tested paradigm where basically the process of cultural evolution is simulated by having participants come into the lab and do some tasks. So it can be a referential communication game, as in this case, it could also be some other task. And importantly, the output of those participants, for instance, toward the end of the task, is then used as input for the next participant or dyad of participants, which means that together these participants form a chain of generations or simulated generations of a process in which they simulate this process of cultural evolution, where a behavior is learned by observing that behavior in others who have themselves learned it in the same way. So they have also learned it by observing that behavior in a previous generation and so on. And again, a brief preview, our research proposal consists of 3 sub-questions. The first one is about the specific interactions between perspective taking and the emerging communication system in such an iterated learning paradigm. There, our question, which I will motivate in a minute, is can perspective taking improve through the establishment of a conventional signaling system? And if so, does this lead to a two-way positive feedback loop between perspective taking and convention formation? The second sub-question is about the isolated interaction between repair and the emerging communication system. Similar question, so does the efficiency of conversational repair improve through the establishment of conventional signaling system, conventional signaling system? This question is motivated by some recent ongoing modeling work that I've been doing, which I will talk about a bit later on in this talk. And then again, the same second sub-question is, if so, does this lead to a two-way positive feedback loop between conversational repair and convention formation? And finally, we'd also like to not just look at these two mechanisms in isolation, but also look at the possible three-way interactions. So how do perspective taking and repair interact with each other in the process of being involved in this emergence and cultural evolution of a novel communication system? So here the question is, how do perspective taking and other initiative repair interact? And what is their contribution at different stages of the convention formation process? All right, now that we have those different sub-questions set out, I'm gonna motivate the first two through my previous modeling work. Oh yeah, before I do so, I just want to emphasize again that this first mechanism that we're interested in is an internal one. So it can be done by an individual by themselves. The second mechanism is an interactive one. And of course, for the third sub-question, that means that it's a mixture of both types of mechanism. This third sub-question is in that sense also motivated by us wanting to acknowledge the complexity that real life communication and cultural evolution of language consists of, right? So language use happens not just in the mind, it happens between multiple individuals. And we would like to, although this adds complexity, we would like to understand those dynamics better between internal and interactive mechanisms. Okay, now I will really motivate those first two questions, starting with perspective taking. So for this, I'll describe in hopefully a very short way my PhD research, which was supervised by Kenny Smith, Chris Cummins, and Simon Kirby at the Center for Language Evolution at the University of Edinburgh. By the way, excuse the sudden change in style, slide style. That's just a reflection of me trying out different styles over the years. So, but it will make the transitions between different parts of my talk extra salient, I suppose. So my PhD was about the hypothesis that language and mind reading have co-evolved through cultural evolution. And basically the aim of my PhD was to use, because this was an hypothesis that had been put forward as a verbal theory by several authors, researchers, and the aim of my PhD was to sort of formalize the assumptions underlying that hypothesis in order to help us understand the conditions under which, or the circumstances under which such a coevolution could get off the ground, and understand the dynamics that would be involved in such a coevolution a bit better. Now, before I motivate this hypothesis, I want to quickly say what I mean by mind reading. So this is a cognitive ability, which is also known more widely perhaps as theory of mind. And what I mean by it is the ability to attribute mental states to oneself and others, and to make inferences and predictions on the basis of these. And it has been argued that language and mind reading have co-evolved for several theoretical reasons. So first of all, it has been argued that mind reading was important for the evolution of language because it allows us to express and recognize communicative intentions. The other way around, it has been argued that linguistic conventions are important for the evolution of mind reading for two reasons. One, because it helps us explicitize and infer mental states. So basically, one way of thinking of what language is that it basically allows us to make explicit what's going on in our mind. And secondly, because language also allows us to transmit our own understanding of how others' minds work to others. For instance, younger members of our population. So what Hayes and Frith have argued is that the sophisticated mind reading abilities that we find in humans are actually a result partly of cultural evolution. So of people transmitting their own understanding of minds to younger members of the population, and that accumulating over cultural evolutionary time. And they argue that language has played a big role in making that possible. So in making it possible for us to transmit our understanding of minds to others. And finally, it has also been argued that language and mind reading form two important parts of a social cognitive niche in which humans evolved. So a suite of social cognitive skills that are uniquely highly developed in humans. So we have some theoretical grounds for arguing that there may have been cultural coevolution between language and mind reading. And one way to sort of test that hypothesis, or at least formalize the assumptions underlying it and explore the dynamics involved, is to use an iterated learning model. But in order to use an iterated learning model, we first need a model of learning itself, so of development. So a quick summary of what is known about the development of language and mind reading from empirical work. It has been argued that mind reading is important in language development because it allows children to infer communicative intentions, which in turn helps them in the process of word learning. Makes sense? The other way around, it has also been argued that language is important in the development of mind reading because it gives children access to conversation about mental states by, for instance, adults in their environment, and also to vocabulary for mental states. So languages, natural languages, at least nowadays, have actual labels for mental states. We have words like thinks, believes, knows, etc. And it has been shown that having access to conversation about mental states and having vocabulary which describes mental states promotes the development of false belief understanding in children, but also adults who were only exposed to an emerging sign language later on in life, or rather they were first to develop this sign language, and later cohorts of that of signers of that sign language developed the sign language further to include signs for mental states, which then improved the false belief understanding of the previous cohort. And this was, the false belief understanding is taken as a sort of litmus test of a fully developed mind reading ability, so fully developed theory of mind. To summarize, we can argue based on these empirical results that there might be some form of co-development between language and mind reading in children, modern day children. Now, how do we capture this in a agent-based model? Well, we decided to take word learning as a test case, and that's because in word learning, the role that mind reading or perspective taking plays is relatively tangible and straightforward. And that's because what we do when we learn a new word is not this. So we don't learn a mapping between the utterance or the word and some object in the environment, but rather what we do is we learn a mapping between some inferred referential or communicative intention in the speaker's mind, some concept, for instance, and the utterance that we observed. So what we're doing when we're learning words is connecting the observed, the utterance, with the unobserved, some inference about what the speaker intended when they produced that word. Now, how do we capture this in a model? Well, we decided to start from a very simple model of what a perspective is, where we operationalize or implement a perspective as a function, or rather a parameter in a function, which maps from a situational context to a saliency distribution over reference. So that means that for this particular agent with this particular perspective, in this particular situational context, some reference will be more salient than others. For this other agent with this other perspective in the same context, that distribution will look different. So for this agent on the right, the triangle and the square are more or less equally salient, and then the diamond shape is very non-salient. That is a different distribution from the one of the perspective or the agent on the left. And this becomes relevant to communication because we assume that a referential intention is chosen proportionally to the salience of the different reference in this distribution. So this perspective, or so the perspective creates a type of mental state in the agent. This mental state is simply a probability distribution over all possible reference, and a referential intention is then chosen from that probability distribution proportionally to its probability. So the more salient the referent to that particular agent, the more likely they are to talk about it. Now, the model as a whole, which forms the basis of both communication and learning in this model, is that, as I just explained, the world creates a context. If you combine that with an agent-specific perspective on the world, that generates a mental state or saliency distribution of reference from which a referential intention is chosen. And then the agent has a second attribute in addition to their perspective, which is a lexicon. And a lexicon is a function that maps from the referential intention to an utterance. So this is the entire model of what an agent is in this model. And this forms the basis for both communication and learning. So another way of summarizing this model is that a context and a speaker's perspective together give rise to a referential intention, which together with a lexicon gives rise to an utterance. But importantly, only two of these factors are observable by or two other agents, which means that if a learner is trying to learn the lexicon of a given speaker, they have to, the only thing they can observe is a set of context with their corresponding utterances, so what the speaker said in that context, and what they have to infer, what they have to do in order to correctly infer the speaker's lexicon is they also have to jointly infer the speaker's perspective, because without having the correct model of the speaker's perspective, they cannot make the correct inference about the lexicon, because it's the perspective together with the context which give rise to the referential intention. So the task or the challenge for learners in this model is to simultaneously infer the speaker's perspective and lexicon, and the learners in this model do that using Bayesian inference. So they have a joint inference task, and they have to start from scratch. So they don't know anything about the perspective or lexicon in advance. In fact, we make it even worse for the learners by assuming that learners start out with an ego-centric bias. So learners start out with a prior probability on possible perspectives, or a prior probability distribution over possible perspectives, where they have assign a high probability to the hypothesis that the speaker shares their own perspective on the world, when in fact in the learning task that we give these learners, we make sure that the speaker always has the opposite perspective to the learner. So this is an unhelpful egocentric bias. Now, to very briefly summarize the developmental results, what we see is that learners can solve this joint inference task using Bayesian inference, but only if two conditions are met. So a learner can only correctly infer a lexicon if that lexicon is at least somewhat informative and the learner can represent the speaker's perspective. So in the red here on this graph, that's just a line at the very bottom at 0, we see a learner who, in a sense, doesn't have a mind reading ability or isn't able to represent the possibility that the speaker might have a different perspective from their own. And in that case, they don't get anywhere with learning the correct lexicon. In the purple, we see a learner who is able to represent that the speaker might have a different perspective, but they receive input from a language or a lexicon that is entirely ambiguous. So that just simply associates every possible signal with every possible referent. So in that case, the learner also doesn't get anywhere. But in all other cases, I'm not showing all other cases here, but just two examples. In the green is a fully informative lexicon. So that's a lexicon with one-to-one mappings between reference and signals. That's when the learner reaches a ceiling most quickly. If they receive input from a somewhat more ambiguous language, which you see in the blue here, they are a bit slower, but they still reach ceiling eventually. So they reach 100% belief in the correct hypothesis about the speaker's lexicon and perspective eventually, as long as there is some information in the lexicon. What we see is that learners can correctly infer the lexicon and the perspective by bootstrapping one from the other. But as I said, this happens only if the lexicon is at least somewhat informative. So that leads to a follow-up question, which is, if we take a population of agents that all develop in this way, but they have to start without any linguistic convention, so they have to build an informative lexicon from scratch, under which circumstances are they able to do so? If an informative lexicon is what's needed to get this co-development off the ground. So in order to investigate that question, we used an iterated learning model. As I mentioned earlier, what happens is that there's a generation of agents in this case who produce some output based on their internal model of the lexicon or of the language. And based on that output, a next generation of learners infers their own model of the lexicon. They then produce some output based on that. That gets given as input to the next generation, and so on and so on. And we're interested in seeing under which circumstances could it go from that case on the top left. So a population of agents that all start out with the same fully ambiguous lexicon, where every possible signal is associated with every possible reference. So there's that lexicon is not informative whatsoever. Under what circumstances can they get from that as a first generation to a final generation, or to convergence on an informative lexicon? So for instance, one that has one-to-one mappings between signals and reference. And what we add to this model of iterated learning to basically simulate these different circumstances that we're interested in is different types of selection pressures. And what a selection pressure does is that it determines the probability with which a particular agent will be selected to get to transmit data to the next generation. So not necessarily every agent of a given generation will be allowed to produce data for the next generation. Whether or not they're selected to do that depends on a certain factor, depending on the particular selection pressure. And specifically, we looked at two different selection pressures. Firstly, a pressure for communication. So here, the agents who are more successful at correctly interpreting the utterances of their own cultural parents, so the agent that they've received their input from, are more likely to produce data for the next generation. And we compared that to a pressure for inferring perspectives, in which agents who are more successful at correctly inferring the perspective of their own cultural parent are more likely to produce data for the next generation. And here I'd like to mention that these different selection pressures can either simulate a form of biological selection or natural selection, where basically agents who are more successful are more likely to have offspring or less likely to die, and therefore more likely to have offspring. But it can equally simulate a form of cultural selection, where it's not to do with death or number of actual biological offspring, but rather the selection takes place by agents from the next generation choosing who they want to learn from based on the success of those agents from the previous generation. Okay, so what results did we find under these different pressures? I'm first going to show you the results in the absence of any selection pressure, so just iterated learning by itself, nothing else. And I'm going to be showing you two different measures. Firstly, the average informativeness of the lexicons in the population, which is basically an objective measure of the lexicon. So it's not based on communicative success between agents, it's just the informativeness of the lexicon. And secondly, I'm going to be showing you the average success at communicating on the left-hand side and perspective inference on the right-hand side. And that is measured between specific pairs of agents, so specifically between the learner and their cultural parent. What we see in the absence of any pressure is that the informativeness of the lexicons quickly converges to the baseline that we'd expect if agents are really just choosing lexicons at random. So nothing is really happening here. And we see that reflected in the success measures because on average, the population doesn't perform much above chance at these two measures. Now let's compare that to the results under these two different selection pressures. So under a pressure for communication on the left-hand side, we see that the average informativeness of the lexicons in the population quickly increases and then remains at a very high level. And the same happens under a pressure for inferring perspectives. But in these two different cases, it happens through a slightly different mechanism. So in the case for a pressure for communication, this is quite a direct selection pressure for informative lexicons, because an informative lexicon, so a lexicon without much ambiguity, is what helps agents communicate successfully. And that is what they're being selected on. So that's quite a direct relationship. In the case of the pressure for inferring perspectives, what happens is that learners who receive input from a more informative lexicon are more likely to reach an accurate estimate estimate of their parents' perspective more quickly, and thereby are more successful at inferring their cultural parents' perspective, which means that those agents that received input from that informative lexicon and therefore were better at inferring their parents' perspective are themselves more likely to be chosen as a cultural parent for agents in the next generation. And that's how informative lexicons propagate. Like once they emerge in a lineage, they will propagate and become more informative until the population reaches some stable plateau. So this is a somewhat more indirect mechanism. And also what's important to understand here is that, well, I'll get to that when I explain the success result. So let's first look at the success measures under these two different selection pressures. We see that the highly informative lexicons have an effect because populations after convergence become not just pretty good at communicating, but also pretty successful at inferring each other's perspectives, even though that's not what they're being selected on under this pressure, right? So this is really just a side effect or a benefit of culturally evolving an informative lexicon. And what we see on the right-hand side is more or less the same result. So populations definitely become better at inferring each other's perspectives. That's what they're being selected on. But because the way they do that is by evolving an informative lexicon, they also become better at communicating. And what's important to understand here is that agents' biological ability to learn about perspectives is not changing in any way over generations. So there's no biological adaptation happening which makes them better at learning about perspectives. The only thing that happens is that an informative lexicon evolves culturally or emerges, and as a result, agents become better at inferring each other's perspectives because having an informative lexicon is useful for learning about each other's perspectives. So to summarize, what we see is that a pressure for either communication or perspective inference will lead to the other skill co-evolving. And in both cases, this happens through the cultural evolution of informative lexicons. So we see a co-evolution happening between perspective taking and the informative lexicon. So as I said, this modeling work forms the motivation for this first sub-question, the interaction between perspective taking and language. And now I will present some other modeling work which I've been doing, which is actually an ongoing project in my current postdoc, which motivates this second sub-question of the interaction between repair and language. So, other initiative repair. This is a project together with Riccardo Dingemanse, on whose current grant I am hired, which is a grant from the Dutch science organization, the NWO, and the grant is called Elementary Particles of Conversation. Now, I'm going to give a little bit of background before I get into our specific model of the interaction between repair and language by giving an example of a previous study that has used both modeling work and experimental work to investigate how structure in a language can emerge as a trade-off between different pressures. So I'm going to be quickly summarizing this study by Kirby and colleagues from 2015 that was published in Cognition. And what they wanted to investigate was the hypothesis that compositionality, which is a type of systematic structure that we find in natural languages, well, in all natural languages across the world, how that might be a result of a trade-off between a pressure for expressivity on the one hand and a pressure for learnability on the other hand. But in order to operationalize these two pressures, they first needed a model, of course, of what a language is. So they implemented a language as simply a mapping between meanings and signals. Here the meanings consist of two features, namely shape and color, and each of those features has, well, I'm using shape and color here as an example. Of course, in the model, it's more abstract than that. But in any case, meanings consist of two features. Here I made them shape and color. And each of those two features has two possible values. So in this case, blue and green for color and square and triangle for shape. And a language consists of a mapping between those 4 different possible meanings and different signals. And the signals in turn also consist of segments or parts which can have 2 possible values, either A or B. And given this very simple model of what a language is, we can identify 4 different possible language types. And those are different to each other in terms of their learnability. So how, and learnability in this model was, or this study was operationalized as compressibility. This is the order in which we'd have to place these particular example languages to have them go from, is that right? Yeah, so from least compressible to most compressible on the left-hand side. The degenerate language simply associates every possible meaning with the same signal, which is very easy to learn. I'm gonna skip the other type language for now. This is just a collection of languages that don't belong to any of the other 3 categories. The compositional language is more compressible than the holistic language, which is because the compositional language can be described in full by simply describing the mappings between parts of the meanings and parts of the signals. And if you have those mappings, you can then generate the entire language, which is a feature of being a compositional system. So a compositional system is defined as a system in which the meaning of the whole is a function of the meaning of its parts and the way in which those parts are combined. So in this case, you see that A in the first position refers to the meaning square, B in the first position refers to the meaning triangle, A in the second position refers to blue, and B in the second position refers to green. If you've described all those mappings between the part meanings and part signals, you can then describe the entire system. Whereas for a holistic language, that is not possible. So a holistic language is a language where each unique meaning has a unique signal, which doesn't have any internal structure to it. So there's no sense in which parts of the signal map to parts of the meaning, which makes this language type less compressible, because the only way to describe it is to simply list for each meaning what is its corresponding signal. Okay, if we want to order these 4 example languages according to their expressivity, we end up with the arrow going in the other direction. Specifically, the degenerate language is not expressive at all. It just uses the same signal for each meaning, which is not very useful for communication. The other type languages are always somewhere in between, and both compositional and holistic languages are fully expressive. So they have a unique label for every possible different meaning. So as you may have observed, these arrows of the compressibility on the one hand and expressivity on the other hand go in opposite directions. The way in which Kirby and colleagues operationalize these different pressures in both their model and their experiment is by having 3 different conditions. So in the transmission only condition, this is where only the learnability pressure played a role, because all that happened is that an individual participant or agent was given input to learn the language from. Each participant comes with their own, learnability or learning limits, and therefore compressibility bias. Their input is transmitted to the next agent or participant, and so on. So only iterated learning happens, but no communication. In the communication only condition, there is no iterated learning. So all that happens is that there are 2 participants or 2 agents that keep communicating with each other. They do keep learning from each other, but a new agent or person never enters the experiment. So that means that there is no novel introduction of this compressibility bias. And finally, to make a condition where both pressures are present, Kirby and colleagues use this transmission plus communication condition, where there's generations of participants, and each generation consists not of a single participant, but rather of a dyad playing a communication game. And what they found, these are the modeling results. What they found is that a compositional language, or the set of possible compositional languages, which you see in the green, take over only when a pressure for learnability and a pressure for expressivity are present. And that's because a compositional language is essentially the most compressible or simplest way to be able to express all possible meanings. And they also ran an experiment in which participants were subjected to these different conditions. And what they found, and so the task was for subjects to describe these 12 different novel objects using a novel emerging communication system. And what they found is that in the expressivity only condition, what emerged was usually a holistic type of language. This was also what the initial generation in a transmission chain, oh no, that's not relevant here. Sorry, this is the communication task. So what these participants were initially trained on was a holistic language, and that's what they still had after a number of rounds of communication. So we cannot identify any structure in the signals that map to like parts of the meaning. So in this case, the meanings consist of a shape dimension and a fill pattern dimension. But we see no structure, as opposed to the learnability plus expressivity condition, in which the different chains ended up with systems that looked like this. So here you see a communication system where the first part of the word tends to refer to the shape, and the second part of the word tends to refer to the fill pattern. And these signals are relatively structured. So the structure or the compositionality is not perfect, but it's pretty systematic across this system. All right, now to our project, we realized that what these previous models and experiments are kind of abstracting away from is the reality of real life language use, which is noisy and messy. So often we have to initiate repair because we didn't hear something, or we were distracted, or things like that. But repair is not part of these previous experiments or models, because they assume that communication is a one-shot event. So the speaker says something and the listener just has to deal with that, like do what they can with it, but they cannot send any signal back. So we hypothesized that if we change that, so if we make repair a possibility, so multiple turns within an interaction, we might see that these different language types, compositional and holistic, have different affordances. And that's because of the following. For a compositional system, if part of the signal was somehow obscured or unclear, a listener or receiver can point to that specific part of the signal and ask clarification about that part of the signal. In other words, they can use a restricted repair initiator. Whereas in a holistic system, oh, right, and the speaker can then respond to clarify just that part of the signal. Whereas in a holistic system, there is no sense in which, given that system, agents agents, because all human languages are in fact compositional, but imagine one would have a holistic communication system, then there's no sense in which we can point to a specific part meaning belonging to a part signal that we may have observed, which means that the only type of repair initiator we'd be able to use is an open repair initiator. Because in initiating repair, we cannot latch on to the part of the meaning that we did understand, because if part of the signal is obscured, then the part that was not obscured doesn't have any meaning in and of itself. It only has meaning if the entire signal has been transmitted without problems. And yeah, the speaker can then respond. So what we're interested in this model is a potential trade-off between these two pressures, that for mutual understanding and a pressure for minimal effort. So what we assume is that agents are trying to reach mutual understanding. The speaker is doing that by trying to avoid ambiguity, so they produce their signals in a pragmatic way. The listener tries to reach a unique interpretation. And if they need to, because the signal was obscured by noise and that made it ambiguous, they will use repair. But they'll use repair probabilistically, depending on the cost of initiating repair. And here we assume that using an open repair initiator is more costly than using a restricted repair initiator. And that's because a restricted repair initiator can reuse part of the trouble source turn, so the signal that was obscured by noise, whereas the open repair initiator doesn't do that. So usually the response to an open repair initiator is the speaker actually repeating the entire utterance. Yeah, so, oh, right, I just explained this. So we assume that a restricted request is less costly than an open request. And we also assume, well, this is not really an assumption, this is just how the model works. We basically took the model from the Kirby and colleagues study that I just summarized and made some adaptations to make repair possible and to add noise, etc. And what happens in that model is that if the dyad that produces data for the next generation uses more repair, given a stable probability or amount of noise, the data that they produce for the next generation will be more useful, because more of the noisy signals will have been clarified through repair. And what we see, or well, the model of learning we used is the same as in that Kirby and colleagues model. So it's Bayesian learning, where the learners are inferring a language, and they receive data in the form of observing actual intended reference by the speaker together with a signal that the speaker sent. And depending on whether noise occurred and depending on whether repair was then used to solve or repair that noise, the signal will be fully observable, or it will be partly obscured. And we used iterated learning, which I've explained before. So yeah, the output of the previous generation forms the input of the next generation. And what we found is that if there's only a pressure for minimal effort, there's no reason for a compositional or a holistic language to emerge, because there is no pressure for mutual understanding. So that condition is not super interesting. We just see a distribution that looks like the baseline distribution if agents were choosing their lexicons at random. If there's only a pressure for mutual understanding, we see that holistic languages and compositional languages emerge more or less in the proportion with which they occur in the hypothesis space. So this is the gray dashed lines indicate that proportion. But it is limited to, or after convergence, the distribution is limited to just compositional and holistic languages, because those are the expressive ones. So those are the ones that allow for communicative success and mutual understanding to happen. And finally, when we combine these two pressures, this effect is not very strong, but we see a subtle tendency for the compositional languages to become more prominent. So this is a subtle effect because it is produced by a pretty subtle mechanism, which is that those agents or those learners that receive input from a compositional language will receive slightly better, clearer data because their parents were more likely to use a restricted repair initiator, or were more likely to use repair because they are able to use a restricted repair initiator, which we assume to be less costly. Okay, so what we see here overall is a interaction between the structure in the systematic structure that emerges in the language and the efficiency of the repair system. And that, well, I'm gonna skip this part. That motivates the second question about the interaction between repair and language. And the third question is simply motivated by wanting to know how these two mechanisms interact together with the emerging language. Okay, so that finally brings us to the research proposal itself, which is, as I mentioned before, about these possible two-way interactions. I hope I have now somewhat motivated where that hypothesis of a potential positive feedback loop in both cases comes from. And this research proposal will be different from the work I've presented so far because it will be experimental work rather than computational modeling work. And specifically, we propose to do 3 experiments. So this is just to give you a broad overview of the proposal. We want to manipulate 2 independent variables, namely whether perspective matters. For this, we developed a novel referential communication task that allows us to manipulate that, and whether repair is possible in that task. So whether interlocutors can take multiple turns within an interaction. In the first study, or the first experiment, we will isolate the interaction between perspective taking and language by making perspective relevant to the task, but repair impossible. In the second experiment, we'll do things the other way around. So there we isolate the interaction between repair and language. And finally, in the third experiment, as I said, we want to look at all these interactions, which means that we turn both of these manipulations on, as it were. So perspective is relevant and repair is possible. And I'll explain to you in a minute how exactly we operationalize this, of course. As I mentioned earlier, we will be using the iterated learning paradigm, which has been tried and tested. And this is just an example of what our stimuli might look like. As you might recognize, these are the stimuli from that Kirby and colleagues study. So we won't necessarily be using these ones, but this is just as an example for what we do want to be characteristics of our stimuli, which is that we want them to vary along, for instance, 2 possible dimensions, such as a shape feature, which you see along this, this x-axis, let's say, and a, for instance, fill pattern or color or something like that, which you see here along the y-axis. And that will allow us to create a set of stimuli that vary systematically along these different dimensions, which will allow for participants to develop a compositional language if they want to, or if they feel the need to. But in addition to that, what Kirby and colleagues did, and what we also want to do, is to give each stimulus a unique appendage. And that allows for a holistic system to arise if that is what happens in that particular experimental design, because it gives each individual stimulus an extra kind of uniqueness, which could be then associated with a unique label that is unstructured as we have it in holistic language. Okay, to give you kind of just a taste of how this experiment will work, and then I'll give you a slightly more detailed idea of what it will look like for the different participants. I'm gonna show you some just mock task instructions that give you a taste of how we want to kind of present the task to the participants. So this is just as an example. The participants might be told something like this as a cover story. You and your partner are stranded on an alien planet. Your task is to gain as many points as you can by working together to collect alien fruits. However, which fruit is ripe, i.e. yields a reward, and which fruit is toxic, i.e. leads to a penalty, changes from trial to trial, and so does their location. Now this is so participants in this study will be taking turns as director and follower within a given block of the experiment. And this is an instruction specific for the director or for a participant in the role of director, which is that only you can see the reward and penalty values of the fruits on a given trial. And the follower has the specific advantage that only they can move around to collect the fruits. So these participants really have to collaborate to gain points, because only one of them knows where the points are, and only the other one is able to actually go around and collect these fruits or objects. And finally, the way in which they can coordinate is that the director can send a signal to the follower to let them know which fruit to pick. So that can be, for instance, a referential signal, a label for that particular fruit or object. Now, what we want to do in this experiment that is different from previous iterated learning experiments is that instead of the referential communication task being one where the director is shown a target object or target meaning that they have to convey to their matcher or follower, and the matcher then being presented with the signal that the director sent, combined with an array of the target item together with some distractor items, we want to add a spatial dimension to this task. And we want to add that spatial dimension in order to make it possible to manipulate the relevance of perspective taking to the task. Ideally, that spatial environment or spatial dimension would be a bit more immersive than the simple grid-based example that I'm showing here. But we'll have to see what's possible given the specific demands of our task. So this is really just to give an example. There will be some spatial feature. The fruits or novel objects will be, for each trial, randomly distributed in this space. And we'll use the spatial dimension to make it so that the director can have a perspective. So this is for the first experiment where we want to manipulate the relevance of perspective. And that perspective is what determines for what objects or fruits the director can actually observe what their reward or penalty value is. So a director in this particular experiment would take a risk if they'd be telling their follower to collect one of these mystery objects of which they don't know the reward value, because they might in fact be a penalty, a toxic fruit penalty object, and they might lose points. So ideally what a director would do in this case is to choose a target. So we will ask them to select their target first, choose a target for which they know that that will yield a reward. Then we'll ask them to type a message to the follower. They might say, for instance, mega wawa. From the follower's point of view, we then see the same exact space with the same exact objects in the same locations. But of course, the follower cannot see the reward and penalty values. All they get is this message from the director. And based on that message, they'll have to select an object to collect. in this case, they made the wrong choice, which means that they'll be losing points. Another difference in our task from a lot of previous iterated learning studies is that we won't be giving participants full feedback. So the follower won't be seeing after they've made their selection what meaning or what object the director intended, because that would make it very easy for them to determine what the director's perspective is. Rather, what they're seeing is just, oh, we lost some points there, and they have to make their inferences based on that. If these participants want to quickly gain points or become better at this task, one strategy they can use is to develop a communication system that is fully expressive, so that has a unique label for every possible object or meaning. And another mechanism that they can use before they've reached that stage of a fully expressive language or communication system is for the follower to try and infer where in the space the director is located, and therefore what their perspective is, and therefore narrow down which objects the director is most likely to be talking about. And the director's perspective will remain constant, stable across one block of the experiment, so across a number of trials. And the participants, as I said, will be taking turns as director and follower. So the follower will understand what it means for a director to have a perspective and how that affects how they play the task. So basically, inferring your partner's perspective will help, or should help, participants establish novel communicative conventions. And establishing those conventions in turn should help them infer their partner's perspective. Then for the repair experiment, here what we'll do is there won't be any perspective that plays a role, so the director can see all the different reward and penalty values, but we will allow the follower to send a message back to the director. So that is what could allow these participants to develop a system for initiating repair. So they will receive a message from the director, and then they can say whether or not they want to send a signal back. And they might develop some convention to indicate, I'm missing part of the signal. In this case, I understand which shape you mean, but I'm missing the part of the signal referring to the fill pattern, for instance. Of course, this is something that participants, this is an affordance of the task that participants will have to discover themselves. So we'll have to pilot this and see how this works. But that's the basic idea. So repair is possible, and the director might then clarify their original message, which could improve this pair's performance. This is just a summary of what I showed before. This is how we'll manipulate these different independent variables. And just to give you an idea of the timeline of the task for a single generation, each generation will first be trained on the system, either the output of one of the participants from the previous generation, or if they are the first generation, they will be trained on a holistic unstructured language. That would be the same as in the Kirby and colleagues study. They will then do a block of this referential communication game, where they take turns as director and follower. We will then have them, after each block, have them do a quick task to map signals to reference. So basically we show them a referent, they type a signal, and that's it. So we can check how their lexicon mappings kind of evolve over time. And if they are in experiment 1 or 3, we also have them do a quick estimate of where the director's perspective or their partner's perspective is, and also do kind of a Likert scale thing of how sure they are about their estimate. And they enter a new block. They play the same referential communication game, except that now, if they are in the perspective taking experiment, the perspective of the two participants changes, so they'll have to re-infer each other's perspective, which may have now become easier because they may have established more communicative conventions in the previous block. We can check their mappings, their perspective, belief, and so on. And then the output of one of those participants in the after the last block will be passed on to the next generation. In terms of measures, in order to answer our questions, we'll measure the communicative success, of course. We'll measure the structure of the communication system. So this has been done in previous iterated learning experiments as well, where the structure measure is just some way of looking at the correlation between part meanings and part signals and the distance between them. We will, as I said, measure the accuracy of the perspective estimate and how that changes over trials and also over blocks of the experiment, but also over generations. And finally, we will measure whether or not repair initiators emerge and evolve, and also whether different types of repair initiators emerge to indicate different things, such as a restricted repair initiator and an open repair initiator or something like that. Okay, so then finally our predictions for the first experiment are that building a communication system will help infer perspective, and that a better perspective estimate will lead to quicker convergence on conventions. For the second experiment, we predict that the emergence of repair will lead to quicker convergence on conventions, and that the emergence of a multi-signal repair system, so where there are different types of repair initiators, will lead to better performance. And finally, in the third experiment, we predict that when there's difficulty inferring the perspective of the partner, there will be more reliance on repair. And the other way around, if repair doesn't emerge because participants don't discover that affordance, then there will probably be more reliance on perspective taking. Okay, that's it. Thank you very much. And I would really love to hear your feedback on our proposal. I guess I'm going to stop sharing my screen. Yeah, I don't yet see you all, so maybe just start talking if you have any questions or any remarks. I'll try and also keep an eye on the chat. If I can find it. Oh.
So maybe I can.
Yeah, someone raised their hand. Peter.
Hi, so Marieke, this is really interesting and thought-provoking. I don't know how closely you followed Riccardo and the other studies in Danish is difficult, or the Puzzle of Danish project,
Right.
You know, where you seem to see differences between Danish and Norwegian in that Danes seems to have a hard time understanding each other, but they're quite good at coming up with repair mechanisms, right? So would you think that the differences between Danish and Norwegian, and maybe Riccardo could comment on that, would in a sense be two instances of some of those prototypes that you would be talking of?
Yeah, I'm wondering. So of course, what we've been looking at, or what we've been thinking about when we're thinking about our hypotheses and predictions, are based on this difference between a holistic communication system and a compositional communication system. And although Danish is maybe a bit different, it's still a compositional language, of course. So I guess it doesn't directly map onto that distinction. But I think on the more abstract level, where repair is more relevant when the system itself doesn't give you as much information about the intended meaning, that is in line with our prediction. So if indeed the finding that you're describing is that Danish people initiate more repair, or do I understand that correctly?
Riccardo, you could probably fill in with the details here.
So that was our hypothesis, that you have a signal which is harder to parse because of the reduction of consonants, and therefore we would get more repair. Actually, funnily enough, what we see is that there is a trade-off. So the Danes tend to use fewer repairs, especially when they tend to align to themselves and to each other more. That is, they repeat each other more, making the common ground stronger, but they don't use the repair. So they anticipate the lack of potential understanding, and that seems to result in not repairing as much as Norwegians.
Right, yeah. So yeah, unfortunately, that would be a hypothesis that we wouldn't specifically be capturing in this particular research proposal, because we decided to focus on perspective taking and repair as the mechanisms, and not on interactive alignment in this case.
But it's an interesting situation where, in a sense, the perspective taking seems to be what is lost in that situation, right? So in order to be able to understand each other in this situation, you have to align so much that you don't need to take the other's perspective. So it's just, it seems to be kind of a nice extension, actually, of the hypothesis.
Yeah, for sure.
Right?
Yeah, absolutely. Yeah, thanks. Okay, yeah, some people had to leave. Any other? Yeah.
Maybe I can come in with another question, because I thought it was really interesting to see how the kind of the perspective taking and the communication was co-emerging, as a or co-evolving together. Was that a surprising finding, or has anyone previously been assuming that? Because that seemed to be a very beautiful, almost property of a semiotic system, that they co-evolve.
Yeah, so it has been proposed as kind of just a verbal theory by some people. Not a lot, maybe, but I have read a couple of papers where it has been proposed, for instance, by, I think, Andy Whiten and Erdal have a paper about this social cognitive niche, where they hypothesize that humans evolved in this social cognitive niche, and that language and mind reading are two aspects of that suite of social cognitive skills that are highly developed in humans. And I think they mentioned somewhere in that paper that there might be some coevolution that has happened between language and mind reading. It has been, somewhat hypothesized by others as well. So Michael Tomasello, Kim Sterelny. So basically theorists of human evolution. And I think it has gotten more meat in a way since Celia Hayes somewhat more recently proposed that mind reading might to some extent be culturally evolved, which makes it a more kind of straightforward dynamic of cultural evolution, because language is of course culturally evolved, but if mind reading is as well, then it's kind of easier to imagine how they would have interacted in a co-evolutionary fashion.
But still, I think your claim seems a stronger one, right, than the Celia Hayes and Chris Frith's point, because here it's almost like a property of a communicative system that it pulls these things along. And in that sense, it seems like a more foundational statement that I think they come up with, where in a sense they're just placing it in some relatively black box notion of cultural evolution. But here it's almost like an inherent property of those type of communicative systems that actually those two things happen in parallel. I think that's a really interesting finding.
Yeah, oh, well, thanks. Yeah, I mean, a more perhaps critical way of phrasing that would be to say, well, you just built it into your model, right? Which to some extent is true, in the sense that in the model of development, we assume that perspective taking is somehow relevant to the task of learning the lexicon correctly. And that is what eventually creates this effect over evolutionary time. But yeah, we felt that was a justified assumption, that perspective taking is somewhat relevant to the task of learning a language. And this result sort of falls out of that. If you combine it with assumptions about possible pressures that acted on humans during the cultural evolution of language. Oh.
Nice.
So can I follow up on that?
Yeah.
So I think that in a sense, the design that you had in that simulation was fantastic in the sense that it allows you to make a strong claim. A potential follow-up, not for this project, but for something else, could also be to see if you allow the, let's say, biological component to also evolve.
Yeah.
Would you get a change in the evolutionary pressure to the biological component as the cultural component merge? Or would you, like, how would the trade-off look like?
Yeah, that would be really interesting to do. I did do some of that, not exactly what you're proposing, but something similar in my PhD, where I also looked at combining this model of perspective taking and lexicon learning with pragmatic reasoning, and where I looked at what happens if pragmatic reasoning is kind of a genetically inherited trait. And there we saw that if basically the trait of being pragmatic can kind of lock you into a system that is somewhat more ambiguous, or a language type that's more ambiguous, because pragmatic agents are able to deal with more ambiguity than literal agents. And by being able to deal with that level of ambiguity, they kind of don't have the same pressures for developing a fully informative system. And thereby they kind of, by becoming pragmatic, their system becomes more ambiguous, and therefore the trait of being pragmatic spreads through the population, because that is now the only way in which agents can communicate successfully, essentially. So they're in a way getting stuck in a cultural evolutionary trap. You could say that's one way you could phrase this, where there's no way out of being a pragmatic communicator. But what we haven't done is run that same kind of genetic inheritance alongside cultural evolution for the skill of perspective taking by itself, which I think would be definitely really interesting. Yeah. And yeah, so I'm trying to think online and hypothesize about what I predict, because there's been some earlier work by Bill Thompson showing that basically cultural evolution can kind of mask the strength of an innate bias from this process of natural selection, which means that then only a weak bias evolves and gets amplified by cultural evolution, and then natural selection doesn't have anything more to work on to make that bias stronger. I don't know if that would directly map to this model, because it's not really a model of a bias, an innate bias evolving, but it's a model of an innate ability to take perspective evolving. But I could see some dynamic like that happening, where at some point natural selection loses its grip because the strength of cultural evolution for amplifying some of these skills or improving some of these skills is strong and fast as well. So it can happen on a shorter time scale than biological evolution. Yeah.
I had a association thought question, but I don't know if it's relevant or anything, but I mean, you can say it reminded me a bit of the lexicon thing, reminded me a bit of the gender debate. Where
sorry?
The general debate.
Okay.
Having kind of clear things to call things makes it easier to take perspectives, and that
right.
find this harder as you dissolve those categories. And then, so in general, maybe we sometimes end up making too simple lexicon in order to make it easier to communicate. Maybe like the gender role, but I can imagine you could run into this in more general linguistic situations where, in order to distinguish colors or something, we simplify. Does that make sense?
Yeah, that does make sense. Yeah. And in fact, for gender roles, I would hope that these categories dissolve in the future. Yeah. But yeah, that's a very interesting hypothesis. So yeah, this and some experimental work has also been done on like also iterated learning experiments where a language evolves so in different conditions where different kind of dimensions of the meaning space are relevant or not. So some dimensions might just be given by the context and some others have to be expressed. And then you see that the communication system indeed adapts to those conditions, right? So that's work by James Winters, which shows that, yeah, the system adapts to contextual predictability and to the demands on the system, basically.
Because you showed the picture with the stimulus that had the shape and the filling. And then there was also the little tails.
Yeah.
Different for each of them. And you can imagine in a compositional language, you would forget the little tails because you don't have a way of really communicating them.
Yeah, that's right. Yeah.
I didn't even look at them because you were talking about fillings and shapes.
Right. Yeah, they're a bit less salient in that system as well. Yeah, that's true. Yeah.
Maybe in general, it becomes necessary to try and make people's lexicon similar as well. Or, I don't know, make people think about the world in similar categories and so on, in order to make perspective taking easy.
Yeah. Yeah. So, yeah, in that model, it's definitely the case that if you share the same lexicon, it will be easier to correctly infer the other's perspective. But I guess in a more real life kind of model of what a language is, right? It's meanings or concepts are not that straightforwardly defined as they are in such a simple reference signal mapping system. Yeah, I think definitely if we align on even our categories in addition to the labels for those categories, it will become easier to understand each other, would be my prediction. But this model simplifies away from that problem of first aligning on categories, right? Or on how we categorize the world in the first place and where concepts come from. It just assumes that reference kind of exist in the world, which is not really the case. No.
But so maybe there's some kind of trade-off between flexibility and easiness of perspective taking.
Flexibility and easiness. So
if we align more and have simple categories, it's easy to understand, but then suddenly there's no such thing as non-binary people.
Right. Yeah, that's right. Yeah. Yeah, that's a very interesting hypothesis. I haven't looked at it that way yet. Oh, nice.
But super cool talk.
Thank you. Thanks. Yeah, sorry, I'm aware that I took quite a lot of time for the talk, so I understand if people have to leave.
No, that was absolutely great, Marieke. Okay. I think the questions are coming to an end. Fingers crossed for the Marie Curie application.
Thank you very much.
As you can tell, it really resonates with kind of ongoing ideas here, so it would be so great to welcome you. If at some point, once we can start traveling physically again, you want to come up here to see people, let us know. It would be a pleasure to meet in person and do the things that we can do in a meeting room, but not in a Zoom room. So,
yeah, that'd be great. I'd love that. So thanks for the invitation.
Take care and see you next week. Bye.
Okay.
Bye.
Bye-bye. Thank you very much.